Next thing we're doing is going to cover identities and inverses. And so what we see here is we have a couple different identities as well as their related inverses. When 0 is added to any real number, the result stays the same. And that's what this states right here. A plus 0, which is nothing, a plus nothing, is the same as 0 plus a. It's going to leave our value alone. The expression will not change. When 1 is multiplied to any real number, the result stays the same. A times 1 is equivalent to 1 times a, which equals a. We see that identity show up a lot with coefficients and variables. If we don't have a coefficient listed, we assume that it is a 1 because of this identity. Now we can look at some of these inverse properties, and we use these inverse properties when we look at the properties for solving an equation. The inverse properties are what we end up using. So the sum of a number and its opposite is always going to be 0 because they are on opposite sides of the number line, and we refer to this as the additive inverse. The additive inverse, a number plus its opposite will always equal 0. And then we use this when we're dealing with fractions and division, and we'll also use it with many other properties, is the multiplicative inverse. The product of a number and its reciprocal is always 1. So in general terms, the easiest thing to think about with additive inverse versus multiplicative inverse, additive inverse, we're switching the sign. If I could spell. Switching the sign. Versus multiplicative inverse is the idea that we are flipping a fraction in order to get a reciprocal. So let's look at a few examples of their inverses, additive and multiplicatively. The additive inverse, we're just going to change the sign. Change the sign. So the additive inverse of negative 7 is 7. For 4.7 is negative 4.7. Negative 3/8 is 3/8. 1 is negative 1. 0 is special because it's its own additive inverse. There is no positive or negative 0. It's just 0. And then 1/5 becomes negative 1/5. Then we can look at the multiplicative inverse, which is flipping the fraction. We do not change the sign. So if it starts negative, then it's going to stay negative when it comes down here. So negative 7 becomes negative 1/7. We write it as a flipped fraction. 4.7 becomes 1/4.7. And if we want to simplify, we can by multiplying the numerator and the denominator by 10 to get rid of that decimal in the denominator. Negative 3/8 becomes negative 8/3. 1 becomes 1. It stays as 1. 1 is its own multiplicative inverse. 0 becomes undefined. 0 becomes undefined. That's because if we take 0 and we write it as a fraction over 1, and then we flip that fraction, let me draw a little loop that we're flipping it, we get 1/0, and we know that anything divided by 0 is undefined. So that's going to be special as well. And then last but not least, the reciprocal of 5/1 is 5, or 1/5 is 5/1, which simplifies to just the integer 5.